Here's an example where our a value is not equal to 1. So when I say our a value, you can think of it in terms of ax squared plus bx plus c, or you can think of it in terms of y equals a times the quantity x minus h squared plus k. In either case, these a values are going to be the same. So we want to, of course, put this into vertex form, and we're going to do that by completing the square. So I have y equals, in order to complete the square, when a is not equal to 1, we need to factor out that -2 from the first two terms. So the variable terms need to have the -2 factored out. So that's going to give us -2 times the quantity x squared minus 6x. I'm going to put a plus sign and a little blank so that I can complete the square. The minus 16 is our constant that we put on the outside of the parentheses. I'm going to take 6, I'm going to cut it in half, and then I'm going to square that. So half of 6 is 3, 3 squared is 9. Now 9 is inside parentheses and it is subject to the distributive property. So what we really did was we subtracted 18 by putting that plus 9 there. We're taking away 18 from the original equation. So we have to take that and put it right back. So the additive inverse of -18 is positive 18. And that zeroes out what we've just done. Now I'm going to write this as a binomial squared. So x minus, and then that 3 just comes right down here, plus 2. Now we have a minus because our original linear term here was a minus. And then on the outside of the parentheses, we get the positive 2 from -16 plus 18. So our vertex is 3, 2. The -2a, a is less than 0, therefore we have a parabola that opens down, giving us a maximum y value. Our axis of symmetry is going to go right through the vertex, so it will be at x equals 3. It is definitely an equation of a line. We have a maximum, and that maximum is equal to 2. This is no coincidence that the axis of symmetry comes from the x coordinate of the vertex, and the maximum and minimum, either one, whether you have a maximum or minimum, that's always going to come from the y coordinate of the vertex. So we have a maximum equal to 2. The input for that maximum is 3. We're going to try and find x-intercepts, and we're going to try and find y-intercepts. So the first thing I do is I start plotting this just so that I can rule out whether or not we have x-intercepts and y-intercepts. So I'm going to plot out the vertex, right 3 up 2. Then I'm going to draw my axis of symmetry. That is a vertical imaginary line that goes right through the vertex. And this indeed is going to be opening down, which means it is going to cross through the x-axis twice. So my x-intercept is the value of x when y is 0. I'm going to put a 0 in for y. And I'm going to use my vertex form to do this. I subtract 2 from both sides. So the positive 2 at the end is subtracted from both sides. I'm going to divide both sides by -2, giving me a positive 1 is equal to x minus 3 quantity squared. I'm going to square root both sides, giving me a plus or minus 1 on the left and x minus 3 on the right. I add 3 to both sides, and I get 3 plus 1 and 3 minus 1. Well, 3 plus 1 is 4, and 3 minus 1 is 2. So those are my two intercepts, 4, 0, and 2, 0. My y-intercept is the value of y when x is 0. I go back to my standard form because it's easier to put 0 in for x and find that we have 0, negative 16. Well, that's going to be way down here. So that's way off the charts. I need to put a 1 in. When I put a 1 in, I'm going to get a point that's between this negative 16 for a y value and this 0 for a y value. So when I put a 1 in, I can put 1 into either equation form. I can either put it into my vertex form, or I can put it into the standard form. And I am going to put it into the standard form. So when I put a 1 in, I'm going to have negative 2 plus 12, which is 10, minus 16, and 10 minus 16 is negative 6. So when I put a 1 in, I get a negative 6 out. I'm going to reflect that over the axis of symmetry, and I'm going to draw my parabola opening down. And there's an example of how to graph a parabola using the technique of completing the square with a leading coefficient other than a positive 1. Now the next problem, we're going to have a leading coefficient of negative 1. So this is what we're going to do in our next example.